Hi, this is Yutong. Today I'm going to present our point level region contrast for object detection pre-training. This is a joint work with Shinley, Alexander, Alan, and Alex. Contrastive self-supervised learning has progressed a lot, showing convincing improvements over supervised setting. MoCo as one of the most representative work, it performs image-level contrast and improves object detection result. But can it do better for detection? Let's first review the key factors that influences the object detection. It usually involves two aspects, correct recognition and accurate localization. MoCo learns good image-level heuristic representation and biased toward recognition, but it lacks more fine-grained representation for accurate localization. Take masked RCNN, for instance, as today's dominant paradigm for object instance segmentation. It first identifies object categories along with their corresponding boxes, and later use them to compute masks for better localization at the pixel level. So why do we think there is room for point-level representations to help retraining? Because the region level and point level representation balances the recognition and localization. Following this, we design point level region contrast. All of the contrastive learning setups contrast something marked in red with others. The things could be images, regions, or point level features. In particular, point level region contrast conceptually contrast at the region level while operating at the point level. What's more, we don't even have to specify the region quality as we do on the left. As shown on the right, we can estimate affinities during representation learning as a proxy for regions. We'll show this is surprisingly robust when introducing the point level operation. For region level contrast, as we observe in the right, with the degeneration of the region quality, it becomes less effective. But with the help of point level operation, it's much more robust. Why is that? As we observed in this picture, when contrasting region A with B, which both contains the sofa point and the dog point, if simply performing region contrast, it invalidates the contrastive pair since the average features are exactly the same. But with point level operation, some effective contrast like A1 to B2 would still remains. Also, operating at point level enables us to bootstrap for potentially better regions during the pre-training process. This is because any segmentation can be viewed as a hard-coded form of point affinities, 1 for point pairs within the same region and 0 otherwise. A natural byproduct of contrasting point pairs is soft point affinities that implicitly encode regions. By viewing the momentum encoder as teacher network, we can formulate the problem as knowledge distillation and improving point affinities online. Here, we show the affinity map from this red reference point after pre-trained with our method. We can observe that with distillation, the region quality is improved significantly. Here's more. In conclusion, with these two parts, our point-level region contrast can be robust and accurate. When evaluating on various tasks of detection and segmentation, we see consistent improvement on these datasets, no matter pre-trained on ImageNet or COCO. Let's compare what is learned with different methods. These figures show the affinity maps to the reference point after pre-training. For image-level contrast, since it ignores the intra-image comparison, it only shows a very small region. For region-level contrast, since it compares inside the image, the saliency regions are larger but is quite blurry due to bad region quality. Therefore, although all three methods show some localization capabilities, ours predict sharper and cleaner boundaries. Here's more comparisons. What's more, we show 4 points is already enough to match region-level results. We also provide more ablations. And more information can be found in our paper. Thanks so much for listening.